Hello, we're going to learn how to draw the VSEPR structure for this anion here. First we need the Lewis dot structure, so we're going to identify the types of atoms we have. We have chlorine and we have oxygen. Chlorine has 7 valence electrons. Oxygen has 6 valence electrons. We're going to have 1 chlorine giving us that 7 electrons plus 2 oxygens, each giving us 6 electrons. Plus, we're going to have to add another electron to account for this charge right here. That -1 is indicating that we have an extra electron. So we get 8 plus 12, 20 electrons. We need to place the less electronegative atom in the center, and in this case that's going to be chlorine. And we're going to have an oxygen here. We're going to have an oxygen here. We had 20 electrons to work with. We just formed 2 bonds. Each of those 2 bonds required 2 electrons, leaving us with 16 electrons in the bank. We can start by filling out the octets of our terminal atoms here, making them all happy. That required 6 times 2, 12 electrons, so 16 electrons minus the 12 electrons we just placed is going to be 4 electrons left over, which must go on this central atom here. Now for our bond dipoles, oxygen is more electronegative than chlorine, so we're going to have bond dipoles that point down the bond towards the oxygens. We need to calculate our steric number, or it's not really something you calculate as much as just count. That is going to be the number of lone pairs and the number of atoms attached to the central atom. So it's got 1, 2, 3, 4. Steric number of 4, and then the lone pair number. The central atom has 1, 2 lone pairs. Now we come down to our graph here. We are at a steric number of 4. We have 2 lone pairs, so we are in this column right here. Our structure is bent or angular. I usually call it bent. This is the same sort of structure that water has, and we can see we're actually, these lone pairs here are kind of being bullies and pushing these guys to be a little closer together than they would typically be, closer or less than 109 degrees that you would predict from a tetrahedron. And we just need to interpret that in our image up here. So we are going to put chlorine in the center. We're going to have our oxygens coming down like this. And then we are going to have a lone pair going into the board and a lone pair coming out of the board. Sometimes I draw this one a little bigger just to help you get that perspective there. The one thing that we didn't do is check our octet, but it is good here. So oxygen 1, 2, 3, 4, 5, 6, 7, 8. Chlorine 1, 2, 3, 4, 5, 6, 7, 8. So this was our correct structure. And we have a electron geometry is always going to be the first one in the column with that steric number. So the first one here is tetrahedral. So it says a tetrahedral electron geometry. That's going to be the geometry when we consider our lone pairs here. And the molecular geometry is going to be bent.